Hello everyone. In this video, I'm going to talk about a topic which is discussed a lot in distributed systems, but many times not understood fully. The topic is quorum. Now, what exactly is quorum? Now, this quorum, in short, is majority. That if you have n number of servers, if more than half of the servers say something, then that's what the decision of the system would be. So that happens in the distributed systems where there are multiple machines. Say there are 10 machines or 11 machines. So you would want to take the decision based on half of those machines, at least half of those. So if you have 11 machines, whenever a request comes, you will decide based on what the majority says. I'll get into the details. We are not going to make call to all the machines, but you get the idea. Now, this is being heavily used in Apache Zookeeper, Apache Cassandra, and similar such distributed systems. So before going into the quorum definition, I'm going to talk about how does the flow look like in any distributed system. So imagine that you have multiple nodes in distributed system. You can imagine them to be different computer or different machines hosted on cloud. So it can happen that one is hosted in one place and other hosted in another place. And then what happens is that these machines would be syncing with each other. So different systems have different mechanisms. Some have heartbeats, some keep on, do some sync operation, which happens among the machines. But overall, they keep on getting synced with each other after some certain duration of time. So this syncing happens. Now, when the client, Alice in this case, wants to get a data, imagine this to be a database or let's say Cassandra, which is a key value store. So let's say Alice wants to get a data, let's say age equal to 10. This key and values were there in the database and she wanted this value from the database, that she wanted to get the value for age. Now, she will make a request to any of the nodes in the distributed system. So it's not that she is going to span her request to all the machines. She is just going to make request to one of the distributed systems machine based on lots of parameters like which system is nearest, which system is accessible, connectivity is fastest, and all those things. And she will make the request. Now, this node might or might not have the data. So imagine these nodes, all these nodes have a local DB and they have the values stored. For example, as I said, age equal to 10 for age equal to 10 for our. So likewise, these data are stored in various nodes. Now, we don't yet know which node has the data. So the request will go to the coordinator node. Coordinator node will figure out with the help of hashing algorithm that, okay, we want to get data for Arun, in which node would the data be located. And then the request will go to that node and then that node will respond back with the data and then Alice will get the data. That's the overall overview, that you will connect to one of the systems and then you will get data from the particular node. In some cases, for example, in Zookeeper, what happens is that read operation gets served from the given node itself if the data is available. The write operation go to the leader node. Let's say this node is leader. So the request will go to the leader node and then that leader will process the request. So that's the overall idea. You can read about how things read path and write path. How do they happen in Cassandra? How do they happen in Zookeeper, etc.? But you don't have to get into the detail. Just imagine that a distributed system works in a way that for outside person, it's just one big system. So for a person who is outside of this boundary, for them, it's just one big system. They can query any of the machines and get the data, even if the data is not available. Because yes, let's say you have 5 petabytes of data. Of course, it's not possible to keep everything in one machine. It would be distributed. So that's why, your request will go to one of the servers and then that's how the flow will work. Now, since you have understood what exactly is the flow, now we'll talk about the replication factor. And now this is also important when we are talking about quorum, so that you understand what's going on. So I think you would have understood or you would be knowing about the hashing part, that whenever a request comes, I take a modulus of the key and then land my request to one of the servers. It's a very common pattern. A lot of people, or in fact online, if you see, you can find the tutorials around that. So that's already there. There is a concept of consistent hashing as well, which helps in many ways. But you can watch a video I posted some time back on consistent hashing. I'll link it. But the idea is that a request comes to a server, and then with the help of hashing algorithm, you decide which machine the request should go to with the help of modulus, etc. Now, it, it is important to note that you will not keep the data, one data in one machine only. So if you take a modulus and let's say modulus comes 0, it's not going to happen that you will keep all your data in just one machine and you will not keep it anywhere else, because then you have a chance of losing the data and you don't want that. So what you do, you replicate the data. You replicate the data to multiple instances of the same cluster. So whenever you take a hashing, instead of getting a one single output, let's say you take a modulus and you got the output as 10, you actually replicate the data to 2 more nodes. And you can fine tune algorithm how you want. But what you do is that essentially instead of just getting one output, you can write a function which returns 3 outputs, that is 0, 4, and 5. So you have that facility, or you can write a mathematical function. In fact, you can just write a simple function as that whenever I get a modulus as 1, I'll also put the data to the nodes which have modulus equal to 2 and 3. Whatever you want, you can do. So, I mean, for the sake of this video, we just imagine that we have the algorithm to give us 3 nodes. So the data will be replicated to 3 nodes instead of 1 node. And that's what is called as replication factor. Generally, in Cassandra, they recommend the replication factor of 5, but in many cases, 3 is also fine. So I worked in one of the places where they were using 3 nodes. So you see here that odd number of nodes are needed because it helps in the majority. But even if it is not there, still you can do have the majority. Let's say you have 2 nodes, but then effectively it means that for majority you need both the nodes. So, or if you have 10 nodes, then for majority you need 6. So you can still do those things, but the recommended value is odd. Now, since we have understood the replication factor, now we'll talk about the consistency level. Now, this consistency level are various. So, for example, let's say a request comes to you. Let's say a read operation or a write operation, whatever. It comes to you in the coordinator node. Now, before giving acknowledgement to the caller that, hey, your request is done, you would want to get the acknowledgement from the dependent services or dependent databases that you would need the acknowledgement for here, here, and here. So consistency level all says that whenever a request comes to the coordinator node, it will wait for the response from all the replicas. So it should not happen that I get acknowledgement from here, but I didn't get acknowledgement from the remaining 2. If I didn't get the acknowledgement from the remaining 2, then I would say that, yeah, it's not done. So the consistency level all means you will get the acknowledgement from all the nodes and then only. So what happens is that a request comes to the server, then it will make the request to the remaining, nodes in which the data lies. So this is the coordinator node, which takes the modulus and decides to which node the data will go. And then they will get the response from all the dependent services. Once they get the response from all the dependent services, then they reply back with ACK. So it is slow, but it maintains the strong consistency. So that's the first thing that you can do. And generally people don't do this, but yeah, it's good to know that you can achieve this one as well. The other one is that consistency level of 1. So here what you do is that when a request comes to your server or your coordinator node, the acknowledgement is needed only from one server. So it's not needed from the other server. So you get a request, let's say a write request, and then you will make write request to one of the nodes. You get the acknowledgement and you will proceed further. So it will wait for the acknowledgement from only one server. So that's the second one. That's the consistency level of 1. But the one which is used in the majority of the time is the consistency level of quorum. So what will happen is that whenever a write operation or read operation comes, you will wait for the majority of the nodes. So if you have the replication factor of 3, that is, you expect the data to be replicated to 3 nodes, then what you would expect is that you should get the response from at least 2 nodes. The moment you get response from at least 2 nodes, you are done. It's done for you. So basically that's the third one. And yeah, if you use this one, then you are mostly fine, because if you get the acknowledgement from the 3 nodes, you can give the data, that what data exactly is there. So what happens is that, let's say you make the write operation, and you make the write operation from the to the 2 nodes, you will get the data and you will make the response. In case of conflicts, so let's say you got the response from 2 nodes, how do you decide which one to consider? So in those cases, they have a concept of versioning and I think global clock in Cassandra. So they have a mechanism to decide which one is the latest one. There are multiple algorithms to decide the latest one and resolve the conflicts. So for example, there is one algorithm called as CRDT. So this is one of the distributed algorithm you can check out. I'll make video on this sometime, in the coming weeks or so. But what they do is that they decide the conflicts, that which one is the latest version, and then give you the data. So you get the data from the given nodes, and then based on the versioning or, global clocks, etc., you decide, and then you give the response. So as simple as that. So that's the consistency level of Quorum, and that's what you should know about. Now, this is a bonus thing, and you can choose to skip it, but I would still love to cover a bit about it. So I'll talk about the tunable consistency in Cassandra, but it can be used in other distributed system as well. So it is important to talk again about it. So the flow is still the same, that the request will come and you will take the modulus, and then you will send the request to the dependent node. So that these things are same. But here, to be always consistent, the following condition should be satisfied. So what happens is that you would want, in some cases, to be write operation to be faster, and in some cases, the read operation to be faster. So it can happen that your system is read heavy or write heavy based on the use case. So if you want your write to be fast, so you would just, in the case of write, you will just get acknowledgement from the one server and give the response. But in case of read operation, what you will do is that you will try to get the operation from the 3 nodes. So all the 3 nodes, and then get the latest one. So this is the definition, that to always be consistent, we follow the following condition, that read quorum plus write quorum, or number of nodes on which you read the data, number of nodes on which you write the data, should be greater than the replication factor. So here, if the replication factor is 3, so greater than 3 means 4. So if you are making a write operation on one node, let's say if you want the write to be fast, you will make the write operation, give the acknowledgement, etc. So in that case, if you want the correct data, then you need to read the data from 3 nodes, that is node 1, node 2, and node 3, and then give the latest response based on the conflict resolution algorithms. So that's one thing. And if you wish the read to be fast, then what you will do is, then when you write the data, you will write to all the 3 nodes. And when you are reading, you can read from any of the 1 nodes. Or if you wish that both the read and write should be at the equal, and you don't want to differentiate, or you don't want to prioritize write versus read, then you can do a 2 and 2 division, that whenever a write operation comes, you will write to 2 nodes, and whenever a read operation comes, you will read from any of the 2 nodes, and then you will give the latest one as a response. So that's called as tunable consistency, and that is the feature which is also supported by Cassandra. So yeah, these are the things which I wanted to cover in this video. I hope this video was helpful. This concept of tunable consistency makes Cassandra very, very strong, because you can define these tunable consistency at the query level. So you can, it's not the database configuration, but a query configuration. So when you are making, let's say, database query 1, so in that you can define the consistency level as 1. But in the query 2, you can define the consistency level as 2. So it's very much configurable, and that makes the things very popular. You can have just one database and multiple services interacting the database, or whatever. So you could, in one use case, have a consistency level of all, whereas in other use case, you can have consistency level of 1. So it just depends how your use case is, what API you are serving, etc. So this consistency level or tunable consistency makes things very, very interesting. I hope this video was helpful to you. You would have been able to understand what's the quorum. It's nothing but majority. And whenever a request comes to any of the nodes in the distributed systems, they will act based on the quorum, and there are multiple approaches to deal with the quorum. The majority decides what needs to be done, but even within the majority, you would take the latest one. So for the latest one, there are multiple algorithms, but the overall idea is that you want to figure out which is the latest. So you do with the help of versioning and other stuff. So yeah, that's it from my side for this video. I hope this video was helpful. Till the next time, bye.